income, entire income profile for their entire life. So if someone earned, let's say, $20,000 a year was their income, and they're, say they're 45, so 20 years until retirement, that would be 20 times 20, $400,000 of income, maybe some discounting. The most that they could borrow and be able to pay back would be maybe $350,000. So you can borrow, you can save as much as you would like, but you can't save more than income. So our household could save, our person could save $20,000 a year and consume nothing, or they could borrow up to $350,000 in this first year, but then they'd spend the rest of their life paying back this loan. Right? But we're going to give them those possibilities, and of course, everything in between, where all the reasonable answers are. Yeah? All right. So just in terms of notation, y is now going to be income. So we have income in period 1 and period 2, y1 and 2. Consumption today and tomorrow, C1, C2, and our interest rate, R. We're going to make some, let's write this out. So our household is going to have a couple of decisions that it can make. In period 1, I'm going to earn income, Y1, and this is going to be equal to what I consume and what I save. Right? I'm just dividing this income cow with my example in half. In period 2, I'm going to have income Y2, but I'm also going to have income from my savings. Whatever I save in this period becomes income next period. I get the S back plus this real interest rate. And then in period 2, the only thing I can do is consume. Just 2 periods, because there's no reason to save for period 3, because period 3, I'm no longer alive. Yeah? So this is, right, we have income side and expenditure side. All right, we can, of course, combine these. Right? S equals, well, savings is just that portion of our income that we don't consume. And then when we substitute it into 2, 1 plus 2, right, this gives us then 1 plus R, Y1 minus C1 plus Y2 equals C2. All right. So now we have to think about our preferences, right? How we value things. We're going to say that our household values consumption. Right? So we like to do something with our income, whatever it might be. And again, remember, consumption could be this stereotypical American consumerism, more goods, buy. But it can also be something else, right? So maybe my consumption is, I want income so that I can, buy some nice benches in the park in my hometown. Right? Or so that I can, as an example, I'm going to buy tents to help set up shelters for people displaced by a hurricane in the north of the country. That would also be, right? Consumption here is just doing something with our income other than saving, whatever we want to do with it. Right? So it doesn't seem reasonable that we like to do stuff with our income. Why would we even be generating Y? Why would we be working if we don't want to do something with it? And we say that we like it in the sense that that first derivative of the utility function is positive. This means everything else equal, if I increase C1, this first derivative is positive, so I'm going to increase my utility, my happiness. The second derivative is negative, so this gives us this concave utility function. We know mechanically this is good for maximization problems. This tells us that we have positive but decreasing. Right? Decreasing marginal utility from consumption. So what does this mean? This means each unit of consumption that I have makes me happier, but it makes me less happy, less additionally happy than the unit that came before. So I like to think of this, I worked at a pizza restaurant for a long time when I was going to college and before. It's a long time working in the pizza industry. And I always say, so when I'm hungry and I get that first bite of pizza, that first slice of pizza, right? More pizza always makes me happy. And that first slice, oh, I'm hungry. Oh, it's fantastic. The second slice is pretty good. By the time I get to that sixth slice or seventh slice, it's not, it's making me happy. Pizza always makes me happier, but it's not making me as happy as that first slice. So that's what we're trying to get here. Okay. We like consumption today, we like consumption tomorrow, but we value them differently. Right. Beta here, if beta were equal to 1, this would say we're indifferent to whether we can have happiness now or happiness later. We would be perfectly patient. Right? If beta is equal to 1, we're probably more, a mythical figure or a figure of religious reverence or the like with this perfect infinite patience. Most human beings don't have a beta equal to 1. Everything else being equal, I'd rather have something now than have to wait for it. No? Right? If we're used to maybe making a decision, so if I wait, then I'll have more. Right? Now, that how much more do I have to get in order to be willing to wait? All that's doing is figuring out your beta. No? If I have to get 10%, I'm willing to wait a year if I get 10% more. That would mean that my beta is equal to about 0.9. So beta is measuring my impatience. If I say, no. If I'm going to wait, you're going to have to give me 50% more. Then my beta is equal to 2/3. Right? So the lower is beta, the more impatient I am. Right? We look at this book. So you can see that this book. But beta is also frequently related to phi, which is the rate of time preference. And so I updated the lecture files as well. So if you go to the online platform, all the corrections that I've done are now have been uploaded. So no matter what, there's always something that can be improved. And what I've learned is if I don't do it right away, I'll forget it, and then I won't get it improved. And then I figure, if I'm going to stop the lecture for a second to improve something, I certainly owe it to you to give you the improvement after. Okay, So this discount factor can be related to the rate of time preference, phi by this way. So beta equals 1 over 1 minus phi. Right, so simply if as phi goes to infinity, right, then beta goes to 0, and we're right, with a discount factor of 0, so we're infinitely impatient, right? Me, now, give it to me. There is, so what's nice, why is this important? The macroeconomic consumption function is a little harder to figure out. Right? We have to look at some aggregate data, but we have to make assumptions about endogeneity and the like that are more difficult. We can start to tickle out these betas, for example. We talked about how much you have to give me to make me awake. We can run experiments or ask people questions. Right? We can give you alternatives. Right? Let me give you an alternative for the curvature of this utility function. You could either, let's two lotteries. One lottery, you get 500,000 dong with certainty, and another lottery you get 1 million dong with a 50% chance, and 0 dong with a 50% chance. Which would you prefer? Think about it for a second.
Can you repeat?
Yeah, so either 500,000 dong for sure, or yeah, so the expected payout is the same, but what would you prefer?
First one.
The first one, yeah? Yeah.
Make sure.
Just give me the money. Give me the money. Yeah? Most people prefer that first one. Okay. So now I'm going to figure out the curvature of utility function.
Yeah, I see the.
Do you still prefer the first one? Yeah. You see what I'm doing here? And what I'm trying to find, that number where you break, where you change, it says, no, I'll take the riskier option. Huh? When I figure this, I can then back out things about the curvature of utility function. And this is, to get to the model, but this is, so I'm going to give you what I think, my favorite picture in all of economics. And it's all about the curvature of utility function. Utility and consumption. And we're saying that this function has a form like this, right? It's positive slope, but the slope is decreasing. And I'm going to compare two different levels of consumption. Think those two there, and their utility. And we can find points, is this in the middle? Let's find the average level of consumption. Right, that's what we started off with there. And if you notice, that level is higher than the average utility. That's that experiment, it's all of this and it's done graphically. This just tells us because we have this concavity, we would always prefer to have the average of a varying consumption, right, over the varying consumption. Our utility from the average is higher than our average utility when it varies.
Jensen,
I'm sorry?
just remind me about Jensen inequality.
Yeah. Jensen's inequality, yeah, exactly. Jensen's inequality is exactly what's going on here. It's that nonlinearity, right? That's very important. And also that we have the difference between the expectation, right, of a nonlinear function, the nonlinear function of the expectation, right?
Yeah.
Exactly that. No? Exactly. Right? Here, this was done with different risk profiles, right? So we would prefer something that's non-risky to something that's risky. This could also be instead of like state 1, state 2, so like if it's heads or tails on a coin, right, that'd be risky. This could also be period 1, period 2, right? Different states of time. No matter whether it's states of chance, states of time, we have a preference for smooth consumption, right? We'd rather it be right, equal to the average than to be varying. Okay. We can also map these preferences, right, and compare these two alternatives. We have here C1 and C2, and we get an indifference curve, right? And we have each indifference curve is associated with pairs of C1 and C2 that lead to the same level of total utility. Right? Now, which of these curves is associated with a higher utility? Which of these has the highest total utility? All right, so if you don't know instantly, that's okay. Let's think about this for a second. We know that this first derivative is positive. So let's just fix one of the levels of consumption. Let's fix consumption 2. So the difference between this curve and this curve, C1 is the same, but C2 is higher. C2 is higher, utility here must be higher. Same thing this third curve here, we've kept C1 constant, just going up vertically. It's associated with an even higher C2. So we must prefer this even more because of our first derivative. So I know then that indifference curves further away from the origin are associated with higher utility. Okay? So my goal here, right, as a household, is to get as far away from the origin as possible. To get onto an indifference curve that's as far away from the origin as possible. All right. And then, we can see, so the way this indifference curve works, so it's giving us different pairs of C1 and C2. Right? If you reduce my consumption today, right, pain, I have to go hungry today. And the question is, how much do I have to promise you tomorrow to leave you indifferent? I don't want to go hungry today. But Alex, if you go hungry today, you'll have a fantastic meal tomorrow, and you'll have a beautiful dessert, and you need to go to a movie. Oh, okay. I'll take that pain because the gain, the promise for tomorrow is so big that it evens it out. And that's all we're doing is tracing these combinations where we trade C1 for enough C2 to leave us just as happy as before. All right, we can combine and put together our budget constraint. We saw we did this together like this here. We could bring, right? Yeah, it's just expressed here in the mirror image. Right, the same equation. Right now, again, we always have to talk to our parents. And now, as an economist, you can talk to your parents using eco-speak. Right? This difference between income and consumption is our savings for our household. Now savings can be positive or negative, right? My mom calls me, Alex, are you saving? Yeah, I'm saving. Of course I'm saving. She said negative. She didn't ask about saving positively. She asked whether I was saving. The answer is yes. It's just negative. Right? In other words, if this savings is positive, this means the household is lending to somebody. Right? We would usually lend to a bank, right? Or if we're buying a bond from the government, we'd be lending to the government. If we're buying a stock, right, we're lending to a company, right, in exchange for ownership or a right to a stream of dividend. But we're taking these resources that we have and we're giving them to someone else in exchange for something in the future. We're lending. If we have our negative savings, we're borrowing. We're getting resources from somebody else. We can write out, make this a little more explicit. C2 is equal to 1 plus R y1 plus y2 minus 1 plus R C1. Right, in the same space, C2, C1, we have the indifference curve. We also have our budget line. Right? Slope here, 1 minus 1 plus R. And we have the intercept. So C1 is equal to 0. Then C2 is going to be equal to 1 plus R y1 plus y2. If C2 is equal to 0, right, we could then solve this, and it would be y1 plus 1 over 1 plus r times y2 would be this point. And we can choose, we can afford any point in between. Right, and let's say that our profile, right, so we have y1 and y2, or these levels here, so we can map them out here. This gives us our budget line, right, where we start with our profile of income. Y1 is here, Y2 is here. So when we look at this, our household, what's higher, Y2 or Y1? Y2, right, obviously. This is a particular income profile. It's probably your income profile. I'm guessing you're probably here, studying, getting a degree, because you have some expectation, some hope of having a higher income in the future than you do now. That's one motivation that people need to study. Right? Okay. Someone like me, right, who's already very, very old, right? I might have a very high income now. I'm getting close to retirement, and I won't be able to teach anymore, so my income in the future might be lower. Right? We can have all different income profiles. Right? We can have all sorts of different income profiles that would still be consistent with the same budget line. You know? We've just picked out an income profile here that's maybe more like your income profile. Right? So this would be your budget line. And if you want to consume more today, you have to borrow. And so to borrow, well, that means you're going to have to pay back in the future. So you'll have to pay back. Right? If your savings is negative, or I'm sorry, if your savings is negative, right? You can afford more consumption than your income. But then tomorrow, your consumption is going to be lower than your income because you're going to have to pay back what you borrowed plus interest. Right? So even if this is your income profile, you could afford this income profile. Borrow some today and pay back tomorrow. You could decide to save today, so your consumption today could be lower than your income, and then tomorrow you'll be able to afford to consume more than your income tomorrow because you'll also have these income from savings. So these are all the points available to you. You can also afford a point in here. Would you choose a point in here? What would that mean if you're on an interior point in here? If you chose consumption to be, you could choose, I don't know, C1 to be the Y1, and then C2 to be here. What would you be doing with the rest of your income?
If we You mean like if we choose C1 equal Y1
Yeah, C1 equal to Y1, but we'll choose C2
equal
to
to
this level, so lower than Y2. You could do that. What are you doing? So I could take money, I can waste. If I choose, I'll probably get, I don't know if I get in trouble, but, right? I could throw this in the trash. I could throw income away. I can afford any point in the interior. But if I'm on the interior, if I'm not on the budget line, I'm being wasteful. Right? And I think all of you would say, yes, Professor Marigota, that's a nice demonstration, but before you actually destroy the money, just give it to me, right? And why? Positive first derivative. Before anyone wastes anything, just consume it. Now in the future, you'll be better off, you'll be happier. So we already know from our preferences, it's not going to make sense to be in the interior, although we could afford it. We're going to be on the budget line. Right? So that's where we want to put our focus. We're going to be focusing on that budget line. All right, so we can figure out consumption. Or maybe you can we can start like, we can choose to be on IC1, this is indifference curve 1, right? With our, the income that we have, we can afford to be in this budget line, and we could choose a point down here. Right, now, the reason how we know that we want to move up this budget line, we want to decrease our consumption today compared to this point, is that on this indifference curve, if I reduce my consumption today and increase my consumption up to here, I would be equally well off. I'd be indifferent between being at this point and this point. The difference is, if I reduce my consumption by this much, then tomorrow I'll not only be able to afford this much consumption, I'll actually be able to afford even more. So I can move up to a higher indifference curve, and a difference curve further away from the origin, by shifting consumption from today to tomorrow. And I'm going to keep doing that, keep shifting consumption from today to tomorrow until I get to here. At this point, if I decrease consumption today further, that's going to allow me to afford this much consumption today, but that's not going to get me back to the utility, the indifference curve I started from. I'll be at a lower indifference curve. I'll be worse off. So I want to be, at this point here, we can figure out graphically, it's the highest indifference curve that we can get onto. There's also something special about the relationship between these two curves. Anyone know?
You mean IC1 and IC2?
No, IC2 and the budget line. So this point here,
Tangent?
yeah, put a tangent. The answer for a question, if you don't know, is
First
derivative. Yeah, take derivative. The derivative of the budget line is equal to the derivative of the indifference curve, right? The point of tangency. Right, so we can pick this out now. Right, so we have we're born with y1, with y1 now and y2. So this is you guys, right? According to this problem, you should, or these indifference curves, you should borrow today, so you're going to have a higher consumption today than your income, and you're going to pay that back, in a couple of years after you get your degree program, maybe a PhD, and you're chief financial officer of a big finance company, the New Ho Chi Minh Finance Center, right? Or whatever, right? Then you're going to pay back, no big deal. Right, so that's the way it works here. We start with our income here. We just set the taxes to 0 for. So we start with this level of disposable income. We borrow in period 1, and then we pay it back in period 2. Now, just visually, right? There's also something different about the sizes of these boxes. Do you notice that? this box is bigger. Why? Trying to capture the fact of interest. Right? Why would we be willing to pay interest? We have to pay back more than we have today. It's the impatience. Yeah? The same thing that says we'd rather not wait for good things means that, yes, it's a bad thing that's going to happen in the future, sometime in the future. So from today's perspective, it's not that bad. No? Yeah, eventually you're all going to lose your jobs. You're going to retire, right? Hopefully things go out right? So maybe you'll stop working when you're 65 or maybe 70, right? Or not work at your old jobs and do something that with your family and the like. So maybe, right? If you cared about the future just as much as you did today, you'd be thinking already today about that possibility. Oh, I should be saving for retirement now. Right? But that's not beta, that's not period 2, that's period 3, 4, 5, 6, that's beta, that's so far in the future, right? I'm not going to think about it. I'm going to discount the problems. I'm not worried about my consumption. I'm not worried about my happiness when I'm 65 years old, because that's so far in the future, that I discount it so heavily that it doesn't matter to me. And even in one period, even though this is a bigger box, from today's perspective, when I discount this with beta, it's the exact same size. Which is why it's on this point of tangency, where we have the slope, the size of this is related to the real interest rate and equilibrium. That's where the increase in the size of the box because of the real interest exactly matches the decrease in the size of the box from today's perspective because of our impatience or discounting. Yeah? So through the lens, right, the lens of period 1, the size of this box is exactly equal to the size of the box of the borrowing in period 1. All right, so now here's another, you can look at this step by step maybe, right? So we see our income today, we borrow against it, so our consumption today is financed through credit, and then we have to pay back this loan, including interest, so the box is bigger, tomorrow. Right, and so we start off at point M, and our optimal consumption is then at point R. All right, let's look at maybe a different income profile. So let's look at point A. So this is someone who has a very high income today, but a low income tomorrow. This is maybe someone who's older and closer to retirement. Right? They're at their highest level of income today, and in the future they're going to have a lower income because they'll be too old to do their job. All right, what do? Well, they're going to save today, saving for retirement, right? So that when they have a lower income, when they're retired, they can finance more consumption than their income alone would provide. Now, there's something really special that's going on here. The important thing is, we already know the answer, it's the derivative, right? It's this margin, it's the slope of the budget line, and the slope of the indifference curve. The slope of the budget line, right, it's determined by this entire, the slope of the budget line is determined by the real interest rate. It's not determined, right, by the exact timing of our income. Look, it doesn't matter whether we have A or M as our income profile. Both people are going to choose R. They're going to save or borrow, depending on their income, the timing of their income. So they both choose exactly the same consumption profile. Right, so the timing of our income is irrelevant. So you can think about this like you can be given an option. If I give you, or if you win the lottery and you win a lot of money today, say $1 billion dong today, or you get you win a payout of $1 billion and $1 billion 100 million dong, 1.1 billion dong in 3 years. Well, use the current interest rate of about 3%. Right, that's, wait a sec. The present value of 1.1 billion dong in 3 years is 1 billion dong. It's the same. The whole point is, well, what would I do with this income? Well, if I get the billion dong today, I'm gonna take my friends out and then have some fun, and then I'm gonna save some so that I can, have a nice, nice life for a while. But what can I do with the 1.1 billion dong that I'm getting in 3 years? If we have perfect financial markets, remember this model, we don't have uncertainty. You've got like a ticket from the government that says, Alex Meyer Gouda will get 1.1 billion dong in 3 years. And I can take this piece of paper, it's got all the stamps and official signatures, and I can go to the bank and say, look, I'm going to get 1.1 billion dong in 3 years. If I give this to you and sign it over to you, how much will you give me today? And the bank will, 1 billion dong. It's the same thing. It doesn't matter whether I'm actually paid out today or if I'm paid out in 3 years in the future. I can calculate the value of that payout today, the present value of that day payout today, and if we have perfect financial markets, I should be able to go to the bank, right, and have them pay out to me the present value of any future promised payout. All right, so if I have a high income in the future, I can borrow against it. No matter any point along this budget line, any income path that leaves my total present value of income unchanged, will leave the budget line unchanged, and so my optimal solution unchanged. All right, so it's not y1 or y2 that matters for our decision, it's this h1. It's our present value of income. It's not the timing, it's just the present value of income. Okay. So before we think a little bit further, we're also going to see an imperfect market. We'll come back to it in a second. We'll see if we can already think about this intuitively. According to this theory, you should, right, so we already established, when I said, you're studying here, you're going to get a degree, you have the hopes of having a higher income in the future, right? Makes sense, you should be able to, according to this theory, be able to go to a bank in Ho Chi Minh City and say, I'm a student at the BGU. Here are my current grades. Look, I just took my exams and I got very good grades. Since my grades are very good this semester, this means my expected present value of income has gone up. Since I've gone to a good university and I've now gotten better grades, I'm much more likely to have an even better job in the future. Give me a new motorbike. According to this theory, that's a very sound argument. And the bank should say, sure, go buy yourself a new motorbike. What do you think would really happen if you go with your report card with your grades from the BGU to a bank and say, I got good grades this semester, I want a motorbike? Are they going to give you a motorbike because of that? Maybe not,
With a loan.
The loan could be for some other, they'd have to charge you more, or they'd want to see, have your parents sign, or what sort of collateral do you have. But according to our understanding of the way the economy works, simply your grades from the VGU alone, if you get good grades, right, this semester, that should allow you to access more financial resources, right? Of course, the better your grades are, the better your degree is, the more likely you are to get a better job. This is very straightforward, right? Right, but not so much for banks. Right? It's an example of an imperfect financial market. Right? The market's going to discriminate. They're not going to want to take that risk, even though it should be a risk they can calculate. Okay. We can now look a little bit closer at these objects here. Let's look at our utility function. And I want to know the marginal rate of substitution. So the rate at which I would like to have C1 exchange for C2. All right, so if I'm at the optimum and I if I'm behaving optimally, if I'm at the maximum, right, then changing, there should be a way to change to improve my utility. Right? It's a first order condition, so we're going to look at this. And this should tell us that any marginal change in C1 should be related to a marginal rate change in C2 of that 4. And we can solve this it's the marginal rate of substitution. Right, and we have, if we equate pictures. Substitution, the slope of our budget line is also called the marginal rate of transformation. That's the rate at which we're technically able to turn consumption in period 1 into consumption in period 2. Right? If we forego 1 unit of consumption today, we can lend it to someone, and then we get 1.2 units of the good tomorrow, so we can trade 1 unit of consumption today for 1.R units of consumption tomorrow. have a point of tangency. These two are equal. And we have then one plus r is equal to u prime c1 over beta u prime c2.
Do the equation.
All right. Now the reason why that is cool, and also why it's also neat to try different routes, we can think of we can also get there differently. What if I asked you to solve for optimal savings or optimal consumption as a problem? What would you do? We have our find 2 star maximize utility. So max u of c1 beta u of c2 subject to okay, as we've seen maximization problems like this, right? What would you do?
First condition.
I'm sorry? Lagrangian?
Yeah.
Yeah, we could write the Lagrangian equals u of c1 plus beta u of c2 minus lambda is c2 minus 1 plus r y1 minus y2 plus 1 plus r c1. Derivative of Lagrangian with respect to c1 equals 0. So we get u prime c1 minus lambda 1 plus r c1. And Lagrange with respect to c2 has to equal to 0. So we get then beta u prime c2 minus lambda.
Lambda
Sorry, this is-
lambda equal to
And if we combine them,
yeah.
we get u prime of c1 equals beta u prime c2 times 1 plus r. Look at the equation in blue. It's the same thing, right? Right, we can also solve the problem in another way. C1, C2, S, U of C1 plus beta, U of C2, subject to, what did we have? We had Y1 equals C1 plus S, and 1 plus R S plus Y2 equals C2. We could write a Lagrangian here. equals u of C1 plus beta u of C2 minus lambda 1, call this C1 plus S minus Y1 minus lambda 2, which would be C2 minus Y2 minus 1 plus RS. Alright, and now we get three first order conditions with respect to C1. U prime of C1 minus lambda 1. Beta U prime C2 minus lambda 2, and now also with respect to savings. And this gives us minus lambda 1 plus 1 plus R lambda 2. And if you notice, this is also why we like to call it the consumption savings problem. Here, the optimal savings, we're just linking, right, optimal consumption at different periods, our marginal utility from consumption at different periods into our savings system. Right? So we get then again the exact same question, exact same answer. So why are they useful? Remember these Lagrange multipliers, they're great tools, right? So we can do a constrained optimization. They also have meaning. Yeah? They tell us something about the problem. They tell us about the tightness of the budget constraint. They give us the shadow value of wealth, of resources. So this gives us the shadow, lambda 1 gives the shadow value of resources in period 1. What's the value of resources in period 1? Well, it's on the margin utility consumption. An additional unit of resource in the first period is equal to the utility that it can give us. We always have the option of just consuming that additional unit of the resource. Right? And it would bring us, for an infinitesimally small unit of additional resource, it would bring us exactly that much utility. Now for period 2, how much would that give us? Well, it would give us, likewise, marginal utility for consumption period 2, but discounted. It's giving us from the perspective of the point of optimization, so our period 1 optimization problem. So it gives us the period 1 value of an additional unit of resource tomorrow. And that gives us the utility tomorrow that we'll get from that additional resource, expressed in terms of today's utility. Right? It's going to make me happy, but that's in the future. So I discount it to give me the value of that future happiness today. And this tells me savings. Well, I want to equate the shadow value of resources today, right, with the shadow value of resources tomorrow, given the savings interest technology that we have. And this already tells us there's another way to think about our household smoothing consumption. So a quick way to see that we have consumption smoothing, just for the argument, assume that beta is equal to 1 plus r. If that's the case, then this condition becomes u prime of C1 equals u prime of C2. And so if an inverse function exists, which for like all normal functions it will, right, we see then that this gives us equal consumption in both periods. So that really is smoothing consumption. That's one coffee every single day. Yeah? Okay, how about we take a 10-minute break?